G'day from Australia. Thanks for tuning in. My name's Ashley Davis and I'm the author of Bootstrapping Microservices. Today I'm going to talk to you about building microservices with Node.js. First though, I'd like to start with the tradition we have here in Australia. I'd like to acknowledge the traditional owners of the land from which I'm broadcasting. I'd also like to pay my respects to elders past and present. I'm just going to get my slides set up. There we go. So, microservices is a pretty large topic. I have to be strategic about what I'm going to have in this talk, and I will be keeping it fairly simple. I'm going to describe what microservices are and why you might want to use them. Then I'll give you a demonstration where I'll bootstrap a really simple Node.js microservice from nothing, and I'll even write a Dockerfile, and we'll build it into a Docker image that we could then easily deploy into production. Please feel free to connect up with me on Twitter. You can see my handle on every slide. That's the best way to stay up to date with what I'm doing, as I put frequent updates on there. I'll just start with a little bit about myself. I'm the VP of Engineering at Optio, and we are building some exciting new products on the Algorand blockchain. I'm also the developer of DataForge Notebook, which I have announced this year. I'm going to open source it. So yeah, stay up to date with that. That's some exciting open source code coming soon for a really cool product. I've written 2 books. Data Wrangling with JavaScript is my first book, and it shows that JavaScript developers, that they probably don't need Python to work with data. Everything you need to work with data is already available in JavaScript. You just need to learn how to use it. And my most recent book is Bootstrapping Microservices, which I have here with me. This is a practical and project-based guide to building applications with microservices using all the latest tools, focusing on Docker, Kubernetes, and Terraform. In this book, I will walk you through the process of building a small but complete microservices application. We start simply by creating a single microservice, which we package and publish using Docker. Then we ramp up to multiple microservices and simulate a microservices application locally using Docker Compose. And eventually we create a Kubernetes cluster and deploy our application to it using Terraform. The content you see in this talk, it's very much related to the book. So if you'd like to see more of it, you can definitely find it in the book. Please hang about to the end of this talk and I'll be giving a discount code so you can get the book a bit cheaper. I also have some big news. I'm currently working on a new book. It's not enough to survive as a developer. We should be able to flourish as well. Rapid Full Stack Development is a book where you can learn from my experience and it can help you grow into a more effective developer. Check out the webpage to learn more. Now, before we get to microservices, let's understand the alternative. The thing we call the monolith is what came before microservices. It's called monolithic because it's an entire application that runs in a single process. Traditionally, this is the most common way to approach development of a backend, and it's still in common use today, so you still see these things. It's not like they've gone away. The typical wisdom is that it's easier to build a monolith than it is to build a microservices application. And that's true to a large extent, but I also want to challenge that notion because I think that with modern tools, good automation, a commitment to a simple architecture, microservices are cheaper and easier to build than ever before. So the choice of whether to go monolith or microservices, it's not as simple as it used to be. Now, what's so wrong with the monolith that we'd like to replace it with microservices? Well, there are some good reasons to start with a monolith. It can be easier than working with microservices, that's for sure. It requires less technical skills. It's a great starting point for building an early stage product or testing a new business idea. It's a great option for a throwaway prototype. And then if your application, if it's always going to be small and if it doesn't need to grow over its lifetime, a monolith can be the right choice. But there are many problems with the monolith, and they're going to make you want to think a bit more carefully about whether or not you would use a monolith. A monolith might start out simple, but ultimately, like any modern application, monolith or microservices, it's destined to become very complex. So you can't hide from complexity by choosing to create a monolith. Monoliths are difficult to scale, both scaling your dev team and scaling the performance of the application. Monoliths are difficult to restructure, and that's something that gets worse over time. Monoliths have a large deployment risk, and that is to say that when you update your monolith, if you break it, you break the entire thing, leaving your customers with nothing. Monoliths have a single large attack surface. If an attacker breaks through that single line of defense, they are on the inside of your application, causing all sorts of havoc. Ultimately, though, it can be very difficult to move away from the monolith, once you're dependent on it. So if your business and your customers rely on the monolith, you have to move very carefully if you're going to restructure it to microservices. You're going to need a great testing regime, that's one thing. If you have a monolith and you don't already have a great testing strategy, don't even start to think about converting to microservices. So, once you have this dependence on the monolith, it can be extremely difficult to get away from it. So if microservices can help, why not choose microservices first? I'm going to get to the benefits of microservices soon, but first let's understand what a microservice is. A microservice is a small independent software process with an independent deployment schedule. Let's break that down a bit. Why is it important for it to be small? Having small services minimizes our deployment risk. It allows for small changes, and small changes can be more frequently deployed and more easily tested. So we can increase our pace of development while mitigating our deployment risk. How small should a microservice be? Opinions are going to vary, different people will tell you different things, but I would say that it should be small enough that you can rewrite it in a couple of days or at most a couple of weeks. So they're fast to replace. That's a key point that I'll come back to later. Why is it important for the process to be independent? Well, that's important for fault isolation, and I'm going to talk about that a little bit in a moment. So then why is it important for the deployment to be independent? Well, that is so that separate services can have their own release schedules, and it means that faster changing services can have more frequent updates. This allows each team to manage the release cycle for their own microservices, and it facilitates the creation of independent and scalable teams. So we've looked at what a single microservice is. Now let's scale it up a bit and understand what it means to be a microservices application. A microservices application is an application composed of many tiny software processes, aka microservices, that work together to build the features of the application. These processes typically communicate via the network. A microservices application is an extreme case of a distributed application where the services have been shrunk down to this micro level. So the difference between a monolith and microservices is that a monolith is just one large process and microservices are many small processes. Both of these options are actually on a spectrum, which I show here with the monolith on the extreme left and the microservices on the extreme right. I'm showing you this diagram because I want you to know that it's not actually just a choice between a monolith or microservices. There's actually many valid points along this spectrum that might work for you and your company. What I'm saying is that your application can be composed of services of whatever size and whatever quantity you want. This all depends, on what you need. It depends on what your customers need or what you're doing for a particular project or a particular company. Now, there are, of course, real benefits to steering yourself towards the right-hand side of this spectrum, but I'll come to that in a moment. Let's first look at this question. Why is it that microservices become so popular right now? I'm sure you've wondered this. Distributed applications have been around for decades. So why are microservices suddenly in the mainstream? Firstly, it's because we have great modern tools. Automation is really important, and the modern tools that we have are all automatable. Because when we have many small services, that's going to be just a huge amount of things to manage, and we naturally want to kind of manage them using automation. Automation is therefore crucial, and especially for small teams who want to scale themselves up to manage large applications. Also, now we have cheap and convenient cloud-based infrastructure. It used to be expensive to run microservices. Back in the old days, we used to run, when we first started with microservices, we were running a microservice on a virtual machine. And so one virtual machine per microservice is very expensive. These days, we used containers to run microservices. That's related to Docker. I'm going to show you how to build a Docker image that you could deploy a container from very soon. And the final thing here is the Devops Revolution and the rise of infrastructure as code. Developers are now managing their own operations. Infrastructure as code has turned application deployment into a coding task. And so individual developers and teams can now manage the entire lifecycle for their microservices. But this is only possible because the services are small, because they're tiny. The services have to be small enough that a single developer or a small team can manage them. Small services being managed by separate teams is leading to more scalable organizational structures. So microservices are popular now because we've reached that point where, in terms of cost, ease of use, automatability, microservices have become very accessible to the mainstream development community. So naturally, we want to use microservices for all the benefits they have to offer. And that brings me to the benefits of using microservices. Now, some people think that microservices make things complex. Well, that could be true, but what I believe is that any application can grow complex. It doesn't matter how you build it. Eventually, it's going to get complicated. And we shouldn't fear complexity. In fact, our primary jobs as developers is managing the complexity that we create in order to solve the problems we need to solve. So what we need as good developers are better ways to manage complexity. And microservices are an architectural style that helps us manage the complexity. A microservices application will become complex, but it doesn't have to start that way either. Just like any new application, a new microservices application can start out very simple. And I show how to start out simple in my book, Bootstrapping Microservices, and I show how to make simple steps towards a more complex application. But like any application, a microservices application, it grows more complex over time. But microservices themselves provide the means to manage that growing complexity. So if you look at any established microservices application that's been around for a while and is supporting an actual customer base, it's going to look complex and overwhelming. But if you zoom in to the level of an individual microservice, that should be small, simple, and easy to understand. That's what microservices are supposed to be. Each microservice should be small, simple, and understandable. Now zoom out again to the entire application. It's still going to be very complex, but you can zoom in. You can zoom into any point, onto any microservice in the application, and you should be able to easily understand how it works. So you can easily understand how the parts of the application work. And the important thing is that no matter how big the application grows, and it could grow to be a Netflix-sized application, if you're lucky, if you're a very successful business, but no matter how big it grows, you can still zoom in and understand the parts of it. That's the crucial thing here, because no one, absolutely no one, can understand the full details of a Netflix-sized application. But we can always put a microscope on the parts and understand each of the parts. Now, you might say that's all good and well for a Netflix-sized application, but I would argue that this ability to zoom in and understand the parts, that's important for any size application, and it doesn't take long before it gets complicated either. So having that ability to zoom in early on and see understand how the parts work, that's very important, and it's something you just don't get when you're working on a monolith. So microservices are important for complexity management. With microservices, we also get a fine-grained level of control over the application. So that allows tight control, really detailed control over deployment, security, scalability, team structure, and so on. Microservices allow us to compartmentalize the components of our application, just like how bulkheads are used in a boat to divide it into components. And just like on a boat that springs a leak, we can isolate a fault to the compartment in which it occurred. So this means that should any microservice fail, the failure can be limited to that single microservice, and it doesn't have to bring down other services, and it doesn't have to cause disruption to our customers. The fact that any given service is small and we can roll it out independently of all the others, that means our deployment risk is kept low. When we deploy a microservice, we only risk breaking just a small part of our application. On the other hand, when we deploy a monolith, we risk breaking the entire application. Microservices support a scalable team structure. The application can be split into many separate code repositories that are managed by separate teams who are independent of each other. Because they are independent, they can work in parallel without treading on each other's toes. This allows us to scale up the size of our application and effectively distribute the workload across a growing company. Now, this is one you've probably heard of. Microservices support scalable performance. With a monolith, you only have a single thing that you can scale, and it's not very focused. There might only be a small part of the monolith that is causing a performance problem, yet you are forced to scale the whole thing. And scaling a monolith, that can get very expensive. With microservices, though, there are more options for scaling. Because the application is already split into components, you can choose to scale only those components that are the performance bottlenecks. So our scaling can be very focused, very targeted, and it allows us a much tighter control over our running costs. Elastic scaling also works much better with microservices because the services are smaller. Because they're smaller, we can spin them up much faster to meet peak demand, and then we can spin them down again quickly when they are no longer needed. So we're not paying for what we're not using, and when we do need to use it, we only pay for what we use. This last thing here I want to mention might not be as obvious as the rest, but it's actually one of my favorites. We can use microservices to isolate our technical debt. So instead of having one huge monolith-sized ball of mud, we can divide it up into separate islands that are distinctly independent of each other. Put it another way, instead of one big pile of spaghetti code, we can separate it out neatly at the application level. And I actually think this makes microservices great for prototyping and MVPs, and it's one of the reasons that I recommend microservices to startups. You get to prototype quickly, not worry too much about the quality of the code, and because microservices are so small, you can easily and iteratively replace them over time with better code. This is designing our application for disposability. When using microservices, we are designing our application to be replaced over time. We are building in the ability to change. But not to mention that, we have pathways to scalability. So we have pathways to building a much bigger application where we can have much tighter control over the performance. Now, I'm going to be giving a live demo today of Node.js and JavaScript. Now, don't think that Node.js is the only thing you're allowed to use with microservices. That is definitely not the case. We're going to be using Docker, and Docker allows you to host almost any language or runtime that you want. You can use Python, Ruby, Go, what other? There's Rust maybe. There's heaps of languages that you can use. I like to use Node.js with either JavaScript or TypeScript, mostly TypeScript these days. Let me explain why. To start with JavaScript, while it's not the world's best programming language, I'll concede that, I do believe it's the world's most practical language. You can do almost anything with JavaScript. Using Node.js means we can go truly full stack. It means we can go anywhere in our tech stack without changing language. So we can work on the front end in JavaScript, we can work on the back end in JavaScript, and so on. I personally use JavaScript and TypeScript across my whole stack, back ends, front ends, mobile applications, and more. Node.js, for its part, was made for this. It was made for building distributed applications. The name Node actually implies that Node.js is intended to be a node in a network-based application. So Node is network orientated, and it includes all the fundamental building blocks that we need for creating networked applications. The fact that Node.js was built for this kind of thing makes building microservices with Node.js particularly easy, and I hope that's going to come across to you in the live demo, where I'm going to show you how easy it is to get started. Passing data between microservices is easy as well with Node.js, and that's because the de facto standard for communication between services on the internet is JSON, and that's something that's built into JavaScript, and indeed it was born from JavaScript. Now, you've also probably noticed that Node.js has a huge community. I mean, that can be overwhelming for newcomers, seeing that there is so much stuff out there. But just keep this in mind, there are a lot of tools, libraries, tutorials, other resources. That's a lot of things to help you get started and to get you the help that you need when you're learning. And more importantly, the community is so huge. So there are lots of people that you can lean on when you need help. And, reach out to us where some of us are really helpful, at least. Now, I think there's a bunch of other benefits to working with JavaScript, and I'm not going to go into those now. Hopefully I've made my case for Node.js. This is a quick summary of the basic needs of a microservice. Typically, a microservice needs some way to communicate with other microservices and possibly the outside world. So it's got a bunch of communication requirements. It also needs to be able to store persistent data. So that's either data in a database or files in file storage or some other kind of storage. Today, we're going to keep things really simple, and we're just going to look at one simple microservice, and we're just going to give it some really basic communication facilities. So we're not going to go too far with this today, and we're not going to explore all these things, but I do explore all these things in my book, Bootstrapping Microservices, in quite some detail. We'll come back to that in a moment. So I'm just going to adjust my laptop. It's time to do a little bit of coding. It's a good time to start your prayers to the demo gods that this all works out for me today. Where's my terminal? So I've got a terminal here already. Now, I'm using Windows 11. Now, it doesn't matter what operating system you use. Everything I show you should be the same. So you can do this under Mac OS, you can do this under Linux. It shouldn't make much of a difference. I have Node.js installed already, version 16.13.1. So if you need to install Node.js, it's pretty simple to install it on all the major platforms. Just visit the Node.js website. Obviously, I also have Docker because I'm going to be building a Docker image out of this at the end. I am running Docker 20.10.12. So to get Docker, I advise if you're on Windows or Mac OS, install Docker Desktop. It's really awesome. It's a little bit more difficult to get working on Windows than on Mac. And there is no Docker Desktop for Linux as far as I can tell. But you can also install Docker kind of in a more manual way on Linux if that's what you're using. Now, I'm going to make from scratch a really simple Node.js application that could be the basis of a new microservice. So I'm going to start by creating a new directory called today. If you're on Mac OS, obviously you'd be using, or Linux, you'd be using makedir, not md. That's a Windows command. Now, to create like a stub Node.js program, we use npm init-y. So npm is the Node.js package manager. It's what we use normally for installing and uninstalling packages from the online Node.js package repository. npm init will basically create like a new kind of project for us, or a new package description. Using the -y command, we'll just default it. So it's going to default to, so I don't have to type anything in basically. If you don't use -y, it's interactive and you have to do a bit of typing. So it just gives you this kind of basic setup. And if we look in the directory here, you can cut the package file. Oh, if you're wondering why I'm using Linux commands on Windows, it's because I think it's because I have Git for Windows installed, which comes with a bunch of useful Linux commands. So it makes using Windows a lot more like using Mac OS or Linux. Anyway, so I've just printed out the contents of the package file there. So this is the package file for Node.js, is the file that kind of manages the metadata for the projects and tracks all the packages and dependencies that we have installed. Now, typically at this point, I've got, well, let's create some code before I get to that next bit anyway. I'm going to open Visual Studio Code from this directory. At this point, I'm basically just going to start by creating a Hello World program. So nothing too exciting. Here's my project open. You can see the package file. We can open the package file and have a look at what's in there. Actually, I don't want to create a file. I want to create a folder. So normally I have a src folder that contains my source code. The typical kind of main file for a Node.js project is called index.js. Sometimes people call it main.js or server.js or something like that. It's fairly common to call it index.js. That's what I like to call it. I'm just going to put a console log in here and just do a hello world. And now we're going to switch back to my terminal and run that. So we're starting pretty basic. So I'm running Node. But I'm going to I give it a file to run, index.js. We get our hello world. So that's our starting point. Now typically at this point, I've got some code. I've got a starting point. It's not much. This is where I might do like a git init to create a git repository, and then every subsequent change I do a git commit, and to save in my source control the results of my coding. I'm not going to worry about git today. That's just adding unnecessary complexity. So let's just pretend that normally I would do that if I was making a microservice. Now, what do I want to do to turn this Hello World program into a very, very basic microservice? Well, I need these communication tools. Communication to be able to kind of talk to other microservices or the outside world, or the ability to kind of accept incoming messages from other microservices. Now, as I said earlier on, Node.js contains everything that we need to do network-based programming. The only problem is the Node.js APIs, as they come, are very low level and a bit complicated and tricky. So most people don't use them. Most people install like a package from the Npm from the Node package repository in order to make this kind of thing a little bit simpler. So that's what I'm going to do today as well. And the first package I'm going to install is Express. So Express is the kind of de facto standard framework for building a REST API or a web server in Node.js. So there's plenty of other options, like I'm using Happy on one project, I'm using Nest.js on another project I'm working on. Express just seems to be the most common and standard one, and actually most of my projects I've ever done have been on Express. So I'm exploring other options at the moment, but Express is still great, and it's still I think it's the de facto standard for Node.js. So I'm just going to install that. So this is going to allow us to handle incoming HTTP requests from other microservices and possibly from external services as well. So once I've installed that and I go back to Visual Studio Code, you can see here in the package file that I've got a dependency now. So it's tracked that dependency. So if I want to share this project with someone else, they just take a copy of it, or they take a clone of my repository and they do an npm install, and they'll automatically get all of the dependencies that I've installed for that project. Okay, so what are we going to do with Express? Well, I'm going to cheat. I'm going to actually go to the Express documentation and copy an example from there, which I've got open here. So this is just expressjs.com. I've just drilled into the Hello World example. This is basically all I need, and I'm not going to do too much more than this. So rather than typing on all this code, I'm just going to copy that in. So it's a nice way to get started. I like semicolons. I can't read code without semicolons. And I'm also going to run the Visual Studio Code formatter to just get this in my standard formatting style. How nice does that look now? So this is just a simple program, requires in the Express library creates an Express application. It's hard-coded to run on local port 3000. We've got a single HTTP route handler here that sends hello world back to the browser. And we're starting the application by listening for incoming HTTP requests. Now, if it starts up correctly, we should see this message printed, example app listening on port 3000. So let's start that. At the moment, I might try running my terminal and my code side by side. So to run this, I run my index.js, and I should have a web server listening on port 3000. Let's have a quick look at that. So let's look at localhost. Yep, that's it, localhost 3000. And if you can see that, it's pretty small. Let's zoom in. Hello world. So not terribly exciting yet, but we're getting there. We're getting there. Now, one thing I want to do is, you can see I'm changing code, I'm editing code. Every time I do that, I've got to stop the web server, I've got to start it again. That's a little bit of a pain. So I want to make this process a little bit faster. I want to have my web service automatically reload, what I call live reload, every time I edit my code. Now, before I do that, I just want to implement, in the script section here of the package.json, I want to implement a start script. I'll show you what this does in a moment. But my start script is going to run node source-index.js. So this is just what we were doing then. It's nothing different, except now that I've implemented that start script, I can use the npm convention npm start to start it. Now, the reason this is important is because it makes your project follow conventions. So typically, whatever Node.js project you get from your colleague or from some random open source person on the internet, if you run npm start, that's what's going to start it. And it doesn't matter whether you've got this index.js or whether you've called it main.js, it'll be set up here to start whatever the file is. And possibly also if it requires command line arguments, whatever it needs will automatically be configured to work on npm start. So it's just set up for nice, convenient, and whatever project you're working on, whatever microservice you're changing to, and you might be working on, a bunch of different microservices, whichever one you go to, you just have to remember npm start will start it. So that's a nice convention. Now, how I'm going to make this work with the live reload is I'm going to install Nodemon. So I'm saving that as a dev dependency. You can see here I've used save dev. So that means it's not a production dependency. This dependency is only for use in development. And what Nodemon does is it's like a drop-in replacement for Node, except it's going to watch my code files. And when my code files change it, it's automatically going to reload them. So you can see here it's added a dev dependency of Nodemon. Now, when you install this for production, when you want to run this on your production server, you're only going to install these production dependencies here. So you don't need Nodemon in production. Now I'm going to update my scripts here to include a new one, and this is not a Node.js convention. It's more my personal convention. Some other people use this or a similar convention. I'm going to run Nodemon, and I'm going to give it that JavaScript file. So this time, instead of running Node like we normally do in production, I'm going to run Nodemon. So this is for running in development. And one thing I have to add here, if you want to run this under Docker, I think you've got to add legacy watch. So unfortunately, the file system watching doesn't work out of the box, and it has to poll. This puts it in polling mode. You only need this if you're going to eventually run this project under Docker, like we're going to do. So now I can run npm, or I've got to use npm run. I've got to use the full sort of convention here because it's not a Node.js convention. npm run start dev. Now I should have an automatically reloading server. So let's say, you can see here what Nodemon is doing is it's saying it's watching for extensions. JS is the important one here. If it sees a change in a JavaScript file, it's automatically going to reload. And it's also run our code. So you can see here it's run our code under Node, and our web server is running. But I could put code here. I could say something like, now I'm going to save this file, And you can see here that Nodemon has said restarting due to changes. So it's starting it again, and this time it's printed that message. So this is a nice way of working where you can actually just keep coding and you don't have to kind of rerun your code. It automatically does that for you. Okay, so let's do a little bit more work on our server here so you can sort of get an idea of what we need. One thing we need is to be able to accept messages incoming from other microservices. So let's pretend that we've got one called, let's make this a to-do application. I know that's very cliche, but it does fit in with the data that I'm going to show you in a moment. Let's say if we get to-dos. So in this case, this is like a query from another microservice, and pretend this is the to-dos microservice that is responsible for getting the to-dos from somewhere and returning them for the other microservices. So we're getting a list of to-dos. That's sort of what the purpose of this is. So this is like a query. It could also be an action. Like it could be like we could use a post, a HTTP post to add a to-do to the database. Or we use a get to retrieve a list of to-dos, or we have a get for maybe a single to-do to return. The reason I'm doing to-dos is because there's this great website called JSON Placeholder. It's great for experimenting with working with REST APIs, and it's just a REST API online. It gives you some examples using fetch. I'm not going to use fetch. I'm going to use Axios in a moment instead of fetch. But it's got a whole bunch of different endpoints. I'm going to use the to-dos endpoint, which you can look at by clicking on it. And so this is the kind of data that I'm going to be working with. It's just available online for anyone to work with. Now, I've got an endpoint here. I'm just going to test that I can do this. So that's going to restart my web page or restart my web server. I have to manually reload my web page to view it. But that's something you can deal with as well. In fact, I've got a blog post and a talk coming up on how to do live reload everywhere in the browser, in Docker. So stay tuned for that if you like this technique of live reload. I can test this here. Oops, got to add some parameters here, and the error message there is telling me that. Let's just refresh the browser. Get to-dos. So that's sort of my placeholder for where I'm going to actually get the to-dos and return them. Okay, so what am I doing? Oh yeah, I've got to install Axios. So, like I said, Node.js has everything you need to do network operations, but it's pretty low level and pretty clunky to use. But you can use it and you can kind of set it up however you want. But most times we use these higher level libraries that makes our lives easier. One such library and kind of the de facto standard for making REST API requests is called Axios. So you might have heard of that because it's pretty popular. But that just makes, oops, forgot I did that. I forgot to do the install command correctly. So Axios will just make our lives a little bit easier when we're making requests to other microservices. Now, just to make this move a little bit quicker, I'm going to copy some code that I've got on my cheat sheet here. So let's just import Axios. So we're just importing the Axios module there so we can use it. Actually, I'll just type this in and I'll have to copy the URL because it's kind of long. So I'm going to do a HTTP GET request using Axios. Now let me see if I can find the thing I'm looking for here. This is the actual, if I go into this to-dos here, this is like literally what I want. I'm just copying from the address bar here. I'm just copying that. And I'm gonna send my GET request at that. Now let's just do that first. And then, so we'll chain up like a handler a promise handler on here to get the response. And the first thing I want to do is just print the response to see what happens. I'm going to print the data in the response. And then There could be an error. There could be an error there, and if I don't have a catch handler, I might miss that error. So just to make sure, like if I put a typo here or something like that, that would cause an error probably, and I might not be able to see that if I didn't have the catch. But let's log the error. So just so I can make that error visible, just in case there is a problem. And I'm just going to send something back anyway. I'll change that in just a moment. So I've got to restart this now after I've installed Axios. And what I'm looking for here is I should be able to kind of hit this to-dos endpoint in the browser. So by the way, I'm just testing from the browser here, but there are other ways to test REST APIs. You might have heard of Postman. That's a really popular one. But in VS Code REST client, there's a really good one called, in Visual Studio Code, there's a really good plugin called VS REST client. VS REST client, Google that. That's a really good way, because this will only get you so far. Doing it in the browser will only get you so far. It works for us today. Right, so I'm just gonna, where's my example? Here we go. I'm just gonna refresh this browser here, and we should see on the side here, on the left-hand side, my console log. There we go. So you can see here a lot of to-do items have been printed out. And it's returned the 1, 2, 3 string that I'd coded in there. Now what we want to do is we just want to send JSON back. So we're responding with JSON, and to keep it simple, I'm just going to return all the data. Now, you know what this is going to do? Actually, before I run this, just for completeness, if there is an error, I don't want to just leave the browser hanging. I want to send a status code of, something went wrong in the server. Status code 500, which is a standard. That's part of the standard HTTP status codes. So I'll go back to here. Now when I refresh this, you should see, too zoomed in, let's zoom out. But here you can see there's a massive list of to-dos being returned in JSON format. So you just have to pretend here that instead of this being in the browser, that another microservice is making this request to get the list of to-dos from the to-do service, and it's getting back this list of data. Now, normally it wouldn't look this nice, but I've got a plugin here that I think is just called, JSON plugin or something like that, that formats it really nicely in the browser. Okay, so now let's look at what else you could do with this system. So you would also want maybe HTTP post to to-dos, and you would say that here, this is where maybe a to-do gets added. And you can have as many of these handlers as you want to handle incoming messages or query requests from other microservices. I'm not going to worry about filling that out. So you can imagine that, and in this case here, we're actually this simulates forwarding a request to another microservice. In this case, because I don't have another microservice, I've only created the first microservice, so there can't be another microservice yet. But just imagine that this is talking to another microservice, but in reality, it's talking to an outside service, an external website. But this could also be, something like, do a database query and return to-dos from database. So, that is what this might actually do instead. But I'm going to leave it as is because I want to demonstrate this in Docker now, and I don't want to break my code. So I'm going to put it back to the way it was. I'm just going to do a quick test to make sure that that is working. So when I put it in Docker, it's going to be all good. So there's not much here. I mean, this is like 25 lines of code, right? But I'm sure you'll agree that this is a simple, effective way of getting started on building a microservice. There's much more you can add to this. We'll talk about that in a moment, about what are the more advanced aspects of microservices. But believe it or not, though, this simple bit of code, this is just simply a great starting point for a microservice. Now, let's Dockerize this. So this should be fun. So just to remind you of the version of Docker I'm using, it's 2010.12. I just want to show you as well that I've cleaned up my computer. I do not have any kind of Docker images locally. This is an empty list of Docker images. I have pre-cached the Node.js base image. Hopefully that's going to work, because otherwise it will take too long to download, and I don't want to wait that long. So hopefully that image is kind of hiding in the background somewhere waiting to be used. Now I'm gonna create an image from this. Now that's like a snapshot of a server, or a snapshot of a microservice, right? So we create the image. We can push that image to our production container repository, and from there we could deploy that a container from that image into a production environment like Kubernetes. But first we have to make the image. So let's go ahead and do that. So typically when making a Docker image, we'll call the file, or the script file that instructs how to make it, we'll just call it Dockerfile. So that's kind of the default name. You can call it whatever you want. And usually I'll have like a Dockerfile-dev or a Dockerfile-prod, because as you'll see in my book, Bootstrapping Microservices, I like to separate out the concerns of development and production. Obviously development, you want convenience of the live reload and source maps and all sorts of other stuff that you don't want in production. And in production, you want to use the kind of optimized and lean and secure. So the needs are different. But for this simple demo, I just only need one Docker file. So the Docker file, it literally is a script file that tells Docker how to build an image of your server or microservice. And you start with a from command. So the from command says, what are you building on top of? Obviously, you don't want to kind of construct, an operating system and, install Node.js and do all that kind of stuff from scratch, because other people have put together these base images that you can rely on. I like to use the Alpine version of the image because it's much smaller. It's not as good for development, but it's much smaller. And that's what I've got pre-cached locally on the system. So hopefully we don't have to wait for that to download. Then you set a working directory. So the working directory is inside the image. So we're going to be working inside the app directory in the image. I'm going to copy across my package file, and also, which I didn't really show you, but you can see it here on the left, there is a package.json file. So the package lock is that one. But the package JSON file is the metadata for the project and tracks the dependencies. Package lock is a generated file that lists dependencies and dependencies of dependencies. So it's a much bigger file, and it locks each of your dependencies to a particular version, which is very important. You need to commit this file here to version control. So because I'm copying package star dot, basically this is going to copy both the package JSON and the package lock JSON into my Docker image. And I'm just going to say that copy that into the current directory. And now that I've copied the package file, I can do an npm install, but I only want production dependencies. So I'm using the only equals production flag here. I want to install production dependencies. So it's going to take that package.json and package lock JSON that we've copied into the image, and it's going to install only the production dependencies. So let's remind ourselves what that is. If we look at package.json, you can see under the dependencies here, that's going to install Axios, that version of Axios, and it's going to install that version of Express. It's not going to install Nodemon, because Nodemon is a dev dependency, so we don't need Nodemon in production. Now I can copy over the source code. I haven't even done that yet. So we're copying the source directory over to the image. That's all good and well. Now, for the most basic Node.js Docker image, the only other thing we need to do now is start our microservice. Can you remember how to do that? Can you remember how to start a Node.js application? It's the same. It's the convention I mentioned earlier. So we say the command to start this Docker container is going to be npm start. So it doesn't matter what the main file is or what command line arguments you need. npm start is what we use to start our microservice, our Node.js application in production. So that's it. That's like a basic Node.js Docker file. I'm sure you'll agree that that's probably not as complicated as you might have thought it was going to be if you'd never seen it before. Now to build that, I can simply write Docker build. Let's just do that. I'm not even going to give it a name. It's so simple. You don't even need to give it a name. I'm running Docker build. The dot there means the current directory, and it automatically chooses to load the file named Dockerfile. So this is going to take just a moment to get through. It's already got Node, so that's great. So that took 0 seconds because I had it pre-cached. If you didn't have that cached the first time you did this, that would take quite a bit longer. So just make sure you give it the time. But you can see here it's running through the different things in my script. It's setting the work directory. It's copying the package JSON. It's installing the production dependencies. It's copying over the source code. And it's writing an image with this ID. So now I can run docker image ls. I can type it right. And I should see that image locally. So you can see there it is, that ID there that it printed at the end here. That's the image ID here. Now I can run that image. So I didn't even give it a name. If I'd given it a name, it would say something other than none here, right? So this isn't very convenient, but I can copy this image ID and I can literally run it from that. I can run the container from that. What's the command line? I'm going to run it in detached mode. And I need to set the port as well. So I need to say that port 3000 on my computer is being mapped into port 3000 in the Docker container. And then I give it the ID. So this should give me my web page. So let's just test that this still works by looking at localhost 3000. Yep, I mean that still comes back with the same thing, so I know that's working. Just to show you that you know that is what's happening. I'm going to stop it. So I'm stopping that. Oh, sorry, I was trying to stop the image. What I need to do is stop the container. So when we ran it, it gives us this big long ID. So I could stop it using that ID. That's the container ID. If I forget what that is, I can do a docker container ls. That lists the running containers. Let me just make this a bit bigger so you can see it. So yeah, you can see here, the container ID that it lists here is a lot shorter, but you can see that it's the first lot of digits from up there. So when you do a container ls, it shows you this shortened ID, and it's actually easier to work with. So I should be able to do a docker stop on that container ID. And now if I refresh this page, it should just hang, or it should give me kind of like no connection or something after it times out. So there you go. So that sort of proves to you that I was actually running a Docker container with the web page there. But let me remove that container. Now I'm gonna show you one last demonstration. I'm going to just remove that. So I should have no Docker. Yep, I've got no Docker images locally. So I'm going to build that again, but this time I'm just going to tag it with hello world. So tagging it basically gives it a name, so you don't have to refer to it as an ID. And you can also give containers names as well, so you don't have to refer to your containers by ID. So now you can see in the list of images, let me just make that a bit bigger so it's easier to read. You can see that it's got a name now, so we've called it Hello World. So you can run it, and I'll just show you that I can run it from that. So I'm running it using the same command here, but I'm going to use Hello World instead. So makes it a bit easier to work with. Now that you've got a Docker image, you're not far off getting this into production. So what I would do now, what I'm not going to show today because it's getting a bit too complicated already, and this is what you can read in my book, Bootstrapping Microservices, is that you would take this Docker image, you would publish it to your private container registry that you've got hosted in the cloud, maybe on Azure, maybe on AWS, maybe on DigitalOcean or something like that, and from there you would deploy a container, and you'd have it running in production. Oh look, our website just came back because I just ran it. Well, that's it for the demo. So today I've given you an overview of microservices and demonstrated how to create a simple starting point for a microservice using Node.js. That is only a starting point. There's much more to learn. I mean, you need to scale up from a single microservices to multiple microservices, and you need other ways for your microservices to be able to communicate. In my book, I show you how to use RabbitMQ to do asynchronous messaging between microservices. You need to be able to test your application. You need to be able to have a continuous delivery pipeline and automated testing. You need to be able to deploy your application to production. And in Bootstrapping Microservices, I show you how to get it working with Kubernetes. So to learn more, please get my book. You can also have a look at my YouTube channel. Let me just quickly show you that. Is it? So my YouTube channel is YouTube, where did it go? YouTube, see Code Capers. There's a bunch of more detailed technical talks on here that you might be interested in. Please have a look. And obviously my book, Bootstrapping Microservices, the whole thing is there. It's going to take you through the entire process of building a microservices application and getting it deployed into production. So it's a really good starting point for learning microservices. And even if you already have some experience with microservices, I guarantee you there's a bunch of useful things in here that you can learn, and possibly some ways of using the tools that you hadn't thought of. There's a discount code on screen for a 35% discount. Thank you so much for listening. It's been an absolute pleasure to talk.